Alright then, so throughout this course so far we've looked at quite a lot of ES6 and ES7 features, and by that I mean modern features. They're in the ES6 and ES7 specification. So these features are things like let and const, promises, async and await, arrow functions, classes, destructuring, etc. But there's a few other modern features I still want to tell you about. It's just that they didn't naturally fit into any of the other sections of the course. So I'm going to do this chapter to cover the rest of the modern features I'd like to tell you about in this course. So the first one of those, or rather the first two of those features that I want to talk about, is the rest parameter and the spread syntax. So first of all, the rest parameter, what does that do? Well, this allows us to bundle up arguments inside a function into a single array parameter. So the best way to understand this is by an example. So I'll do that. I'm going to create a function here, and I'm going to call it double, because what it's going to do is take in a series of numbers and then it's going to spit out an array with those numbers doubled. So let's create the function. Inside the function, we're going to eventually do something here. But first of all, we need to take some numbers in. Now we could say something like num1, num2, num3, etc., depending on how many different parameters we want to take in. But what if we don't know how many different parameters we want? What if we want to call the double function and pass either 3 numbers in sometimes, or 10 numbers in sometimes, or 20? Then we don't know how many parameters to specify right here. So a way around this would be to use the rest parameter. Now the rest parameter looks like this: 3 little dots, then we just call it something, so nums. And what that does is take all the arguments that we pass into the function when we call it, and it bundles them up into a single array parameter. So let me show you this. If I now say const results is equal to double, and then we're going to pass some numbers in, so I can say 1, 3, 5, 7, 9, 2, 4, 6, 8, whatever. Then what we can do is take all of those in, all of these different arguments, as a single parameter, which is now going to be an array. So now if I go down here and I say console.log nums, then what this does is take all of these numbers that we pass in, and it's going to bundle it into an array called nums. So now if we save this and see it in the browser, we can see that this is now an array of arguments. So that's really useful when we don't know how many different arguments we're going to pass in and we want to bundle them up into a single array. We just place 3 dots before whatever we call the parameter, and then that parameter is going to be an array of arguments. So that's quite useful. So now what we could do is instead return something down here. I'm going to return a new array, and I'll do nums.map. So we're mapping this to a new array. We're taking one array right here and mapping it to a new one. And the function is going to take each number inside and return num times 2 because that is doubling them. So that's going to create a new array of numbers which are now doubled. And if we now console.log the result, down here, which is the result of this function, then we should see that array with numbers doubled inside. So let me save this and preview, and we can see now all the numbers have doubled. Awesome. So that is the rest parameter for you. You put 3 dots in front of whatever you want to call a parameter, which will be an array of arguments that we pass in. Okay, so that's the rest parameter. Now, spread syntax is pretty similar, but it kind of works the opposite way. We still use the 3 dots right here, but we use the spread syntax to spread out an array into its individual components. So, for example, let me create now a constant. So const people, and set this equal to just a simple array of strings. So we'll say Sean, Ryu, and we'll also say Crystal. Now then, if I say now console.log and then ... people, what this does is actually spread this array out into its individual components. So we'll see 3 individual things now: Sean, Ryu, and Crystal. So they're no longer inside an array, we've spread them out. And that's kind of what's happening here. We're taking in an already spread out version of arguments, and then right here, because we're saying that we're taking them in as a spread out version of an array, then what it does when we just say nums is it takes the array that's not spread out. So it essentially does the opposite thing. It puts them back into an array. Right here, we're kind of doing the opposite. We're taking an array and we're putting 3 dots in front of that array to spread it out. So a good use case of this would be when we want to take the elements of one array and spread them into another array. So for example, I could say const members is equal to a new array, and say we have a couple of different people in this array, Mario and Chun-Li, etc. But then also I want to put all of the people in this array into here as well. Well, I could just say ... people, and that will spread this array into this. So if it will just unpack the array and put each element of this array into this array as well. So now if I say console.log members and save this, then we can see we get these 3 additional people in the array when we use the spread syntax. Okay, so that's when we use it with arrays. Now I also want to show you how we can use the spread syntax with objects. It's very similar. So say I have a constant called person and set this equal to an object. Inside this object, I want a name property. I'll just say Sean. I also want an age property. We'll just say 30. And we'll say the job is going to be Net Ninja. All right, so now if I come down here and say, okay, I want a clone of this person. Now, remember, if I say something like this, person clone is equal to person, then that's not actually going to create a new object, remember, because objects are a reference type. And all this does is create a new pointer, which is pointing to the same object. So this doesn't make a clone of the object. However, what I could do is make a brand new object. So now I'm not saying just copy this and make a new pointer. I'm making a brand new object. Now what I could do is say ... person, and that is going to take whatever is in this object and spread those properties out into this new object. So now I am actually making a full copy of the object, not just a copy of the pointer. So if I was to now come down here and say console.log person clone, then we'll see this object. We can see it's identical right here. So now I could also, if I wanted to, add other properties onto this. I could say location and put that to Manchester and save it, and that's absolutely fine as well. So this is a good way of creating a brand new copy of another object. And there we go, my friends. That is how to use the rest parameter to bundle different arguments into an array, and also how to use the spread syntax to do the opposite, take an array or an object and unpack that into its individual components. So then the next modern feature I want to talk about are sets. And sets are a new data structure in the object category, which means they're a reference type, and they allow us to store a list of any kind of unique values. And by that, I mean that in any given set, a certain value can only be present once. So these are a bit like an array, but they don't allow duplicates, whereas an array would allow duplicate values inside it. Now that is a massive oversimplification because arrays and sets have totally different methods and properties from one another, but on the surface that is the big difference. So to demonstrate this, we're going to work through a couple of different examples. First of all, notice this, I've got a names array right here. That's just a normal array with strings, but notice we have 2 Ryus inside this, so that is duplicate values, right? But if I save this, we're logging it to the console, by the way. If I save it, we can preview it, and that's perfectly valid. We can have duplicate values inside an array. Now, if I was to pass this array into a set, then it wouldn't allow duplicate values. So let me demonstrate this now. What I'm going to do is say const and then names set and set that equal to a new set. Now, there's no shorthand. way of creating sets, like for arrays, we can use square brackets. When we're creating sets, we have to use the new keyword and the set constructor. So this creates a brand new empty set. But like I said, we can pass an array into the set, which is going to then do its magic on it and eliminate any duplicate values. So let me just copy this array now and paste it in here and save it. Now, if we were to log this to the console, so I'm going to say console.log and then names set and save this. Let's preview this. And now we can see we have this set. It's different syntax from an array. We use curly braces here. And inside we can see we only have one Ryu. So it's deleted essentially one of the Ryus because we are not allowed duplicates in a set. Okay, so that's the big major difference. Now we could also, if you wanted to, just pass the names array directly into a set without explicitly writing the whole array. So let me just comment this out and then come down here and I'll say const names set is equal to a new set and pass in the names array. So let me take that and paste it in here. That does exactly the same thing. Save it and we can still see that set right here. So this idea of sets is good if we ever have an array of data and we want to eliminate any kind of duplicates from that array of data. So we could pass it into a set. But then ultimately we're left with a set. What if we want to eliminate duplicates but be left with an array? Well, what we could do is something like this. I'm going to use the spread syntax on the names set. So if we say const unique names is equal to a new array, and then inside that array I'm going to use the spread syntax and then say names set. So we can use the spread syntax in front of a set, which is this thing. Remember, this set takes in this array and we get a set of values which are unique based on that array. Now we're spreading those values right here using the spread syntax back into a new array. So now if we were to log this to the console, console.log, and then we want to log unique names like so and save it. Then we can see over here now we have an array of unique names. So it took a couple of steps. First we had to put it into a set, then spread that set into a new array. Now we can shorten this whole process by doing this in one single line. So let me now just comment these things out and we'll comment out this. And now what I want to do is say const unique names is now equal to an array. And inside this array, we're going to use the spread syntax on a new set, and inside that set we're just going to pass in the names array, or we could pass this in directly, doesn't really matter. We're passing in the names array. So that makes a set. Then it spreads those values right here into this new array. And that's going to do exactly the same thing. So if I save it, now we can see this brand new array, which has unique values. Awesome. Now, I did say before that it was an oversimplification to say that a set was just like an array, but only allows unique values. And it's an oversimplification because sets have their own unique set of methods and properties. So we can't use a length property on a set or a push method. Instead, we have different methods and different properties. So what if we now create a new set? Let me come down here and say const, and we'll call this ages and set it equal to a new set. Now, there's nothing in there to begin with. We're making a brand new set. What if we want to now add some values to this set? Well, we could say ages and then use a method called add. And then inside the parentheses, we say what value we want to add to the set. So I can say 20. So now if I come down here and say console.log ages, then we're going to see this set. It's just got one value inside it. Now I can do the same thing down here. I could add another value. So let me now say 25 and save it. And now we can see those two values. Now, these are chainable, meaning we can chain them together. I could do add and then another add, and this would be 30. Save that. And now we get that as well. So we can chain these add methods together. Now, what if I try to add a value that's already in it like this? Well, let's try that. I'm going to say ages.add and then 25, which we already have. Save that and come over here, and it doesn't put it in. It knows that it already has a 25 in the set because we added it here, and it disregards this one that we tried to add to it later. So that's how we add elements to a set. What if we want to remove one? Well, we just say ages, then .delete, then the value we want to remove. Now, since all the values inside a set are going to be unique, we're never at the risk of removing multiple values by passing in the value we want to remove. So we could just say 25, and it's going to find that value and take it away from the set. So now we can see we're just left with 20 and 30. Now, I said it also has different properties, and we can't use the length property like we can on an array to find out the length of the set, but what we can do is use ages.size, and this will pretty much do the same thing. It tells us the size of the set. We can see right here, 2. Now, there's also another method we can use called has, and that's to check if this set has a certain value inside it. So say, for example, I could say console.log and then inside ages.has, and I'm going to check if it has the value 30. Now this is going to return a boolean, either true or false. So let me save that and preview, and we can see that this is true because 30 is inside the set. And if I do a different one, I'm going to say ages.has, and then I'm going to say 25, save that, and we should get false because it doesn't have 25. Initially, we added 25, but then we delete it. Then we see if it has it. So it doesn't. Okay, so that's a couple of different methods and properties we can use on sets. There is one more I'm going to show you, and that is how to clear out the set, so to remove all of the values inside it. So to do that, we say ages.clear, and that's going to remove all of the values from the set, and we can say console.log now, ages, to verify that. Save, and now we can see there's nothing in the set. Okay then, so finally, sets are iterable, meaning we can use the for each method on them. So if I wanted to cycle through a set, I could come down here, and in fact what I'm going to do is just copy some data from my repo over here, and you can see this is just a simple set called ninjas. So we set it to a new set, and we're passing in an array right here. We can do that. We've seen that before. So inside this array, we have 3 objects: Sean 30, Crystal 29, and Chun-Li 32. So they're all unique, that's fine. But what if I want to iterate this set? What if I want to cycle through it? Well, I can do that by saying ninjas.for each, and then firing a callback function for each individual ninja inside that set. And we can just say console.log the ninja .name and also the ninja.age. So let me now save this and preview, and we can see over here that this works fine. So there we go, my friends. That is sets in a nutshell. On the surface, they're a bit like an array, but they only allow unique values, but they also come with their own host of methods and properties as well. So the last thing I want to talk about in this chapter, the last modern feature, is this notion now of symbols in JavaScript. So in this course so far, we've seen all but one of the data types, and that last remaining data type is called a symbol. And the main feature of a symbol is that it's completely unique. No two symbols can ever be equal to each other. So what I'm going to do is demo this. I'm going to say const, and I'm going to call this symbol1 and set it equal to symbol. Now notice, we don't have the new keyword here. We're not creating a new symbol object. We're just creating a symbol. And a symbol is a primitive type. So we're creating that symbol. I'm going to create another one by saying const symbol2 is now equal to symbol. And then what I'm going to do is just log one of these to the console. So I'll say console.log symbol1. Okay, save that and preview, and we can see over here symbol. Now I'm also going to log the type of the symbol1. So I'll say type of symbol1 and save this, and we should see that the type is a symbol. Now, I'm also going to log out here symbol2. So I'll say symbol2, comma, and save this. And notice over here, these two right here, they look identical. But like I said, no two symbols can ever be the same. And I can demo that. I'm also going to log to the console down here, console.log symbol1 is triple equals to symbol2. And we should see false in the console, which we do, because no two symbols are the same. Even if this was loose comparison with two equal signs, this would still be false. They are completely unique. Now we can also pass in identifiers to the symbols to describe what they are. So I could say something like a generic name here, and I could even do the same one here, a generic name. And these, even though they're identical here, they would still not be equal. So I could save this and we would still get false, even though they look identical. So what does this all mean then? Well, symbols can be used as keys or property names in objects. For example, we could create a normal object literal now, and I'll do that. I'll say const ninja is equal to a new object. Then we could just add normal properties by saying something like ninja.age is equal to 30, or we could use square bracket notation. So ninja and then in square brackets a property called belt, and that would be equal to orange, like so. And if we want to console.log the ninja now and save this, let's try this, we can see those properties. No, we can't, because we've misspelled ninja right there. So let's save that, and now we can see those properties. Now if I wanted to override one of these properties like the belt, I could say ninja and then the belt again, and this time it would be equal to black. Okay, so if I save this now, it overwrites that property. So it doesn't give it another belt property, and we have two belt properties now. It just overwrites the belt property that we already have. So we can't give an object this way two properties which are essentially the same. Now with symbols, that doesn't matter. These two can look identical, but we can still use them both as properties in an object. So for example, I could come down here and I could say ninja, and then symbol1 is equal to Ryu, and then down here we'll say ninja, and symbol2 is this time equal to Sean. And now if I save this and preview, then we can see that it has both of these properties: symbol a generic name Ryu, symbol a generic name Sean. So these look identical, but they're not. And when we add them as keys to an object, it doesn't matter that they look identical, because technically they are not the same thing, because no symbol is the same. So even though both of the symbols have the same identifier, that doesn't matter, they're still unique. So using a symbol as an object key means that all the keys in an object are definitely unique.